Okay, great. Well, hello everyone, and thank you for joining us for our bonus session in our 2021 Climate Action webinar series. My name is Bill Melby, FAIA, and I am co-chair of the newly formed AIA California Resilient Design Committee, and I'll be your moderator for today. As you know, AIA California has developed an in-depth series focused on understanding and implementing the AIA's framework for design excellence. This series will run through the end of the year and will feature monthly, hour-long general climate action webinars, as well as 90-minute webinars that dive deeper into technical topics like today's. Additionally, AIA California has partnered with various organizations with like-minded goals to bring bonus content to you in the comfort of your own office or wherever you may find us. As always, these webinars, all the webinar content and additional resources will be available on the AIA California website shortly after each session. A few quick housekeeping reminders before we get started. Today's session qualifies for 1.5 AIA HSW learning units for those who are watching live now. And AIA California staff will report these units for you. The session is also being recorded and will be posted on AIA California website with additional resources and PDFs of the presentation shortly after the presentation. As a reminder, please use the Q&A function to ask any questions for today's presenters. You can also like a question and that will move it up to the top of the queue. Now on to today's webinar. In partnership with Energy Code ACE, we're happy to have Gina Rhoda join us again today. Today's webinar is one in a three-part mini-series brought to us by Energy Code ACE. Join us for parts 2 on June 30th and part 3 later this fall. Energy Code ACE is developed and provided by the California State Codes and Standards Program, which offers free energy code training, tools, and resources for those who need to understand and meet the requirements of Title 24, Part 6 and Title 20. These are designed to improve compliance with state building and appliance energy codes and standards. The program aims to advance the adoption of effective implementation of energy efficiency measures and building practices to lock in long-term energy savings. The program recognizes that codes and standards are one of the most effective pathways to ensuring sustained market transformation. And that is key to making them work well in a well-informed industry, professionals, and consumers. With that in mind, a number of offerings have been developed to help both those who enforce the code as well as those who follow it. Today's webinar provides a deep dive into the envelope requirements of the 2019 Energy Code, and that's Title 24, Part 6. We will focus on our discussion on developing details that meet the non-residential and residential prescriptive requirements for compliance that are established, and we'd call a C passing grade. As you recall, the title of this is Making the Grades. So, for a project. We will then talk about what happens when a project's U factor is below prescriptive requirements, which we would consider a grade, a D or an F. And how to compare to exceeding prescriptive baselines, which we call an A or a B, and how that will affect HVAC loads of a building, moisture control, and energy compliance flexibility. I would like to quickly introduce today's speaker before handing things over to her. Gina Rhoda is the principal in Gable Energy, has been in energy modeling field since 1991. She's an instructor and a subject matter expert for Energy Code ACE and the investor-owned utilities. Gina is a certified energy analyst, a CEA, through CABEC, and a lead AP specializing in non-residential energy modeling for Title 24, Part 6, and for LEED. In addition to working on many residential single and multifamily projects throughout California. So with that, it's all yours, Gina. Take it away.
Well, it looks like I have a fan in the room, so that's great. Thank you for inviting me to be here. And this was fun because we decided that I've been here before giving you brief overviews about code updates and where we want to go in terms of compliance to the code. And it was decided we wanted to dive deeper. So we're going to dive deeper and really look at how does the envelope affect compliance of a building and what sort of options that we might have when determining flexibility measures associated with the code. Not going to go through my learning objectives because we just went through those already. As you guys know, I usually have to put those in the deck for an AIA session. Our website, if you haven't been there before, I really hope you guys will after today, is www.energycodeace.com. And we have 3 buckets. And our first bucket is all about tools. And these tools are to help people figure out what they are needed to do for compliance. So such as, what forms do I need? That's the #1 question we still get is, where are the forms and which forms do I need? So there's a lot that supports that particular item. Our newest tool we have here is the Virtual Compliance Assistant, which helps people organize their projects and be able to document compliance in the prescriptive method. And you guys might want to take a look at that at some point if you're someone who does the documentation yourself and you don't hire an energy consultant to do so. We also do a lot of training, just like these sessions here. We have some online self-studies, and we also have some virtual classes where I, plus another suite of instructors, teach full-day classes. We really don't do full day anymore. We break it out over a couple of days because we get it now that we're all online. You just can't sit in front of the computer just doing one thing throughout the day. Am I the only one who seems to be sitting longer in the course of a day since the old stay-at-home stuff going on? But we have some specific classes to help especially architects that I'll be talking about throughout our training and how they can help you guys out after today. And our resources are fact sheets. They're trigger sheets in terms of alteration projects. I triggered this and nothing else just because I'm changing out the windows, just because I'm doing a TI build out. So there's lots of information, just one-sheeters. We also have application guides that go more into depth into how code applies. And a lot of the content I'm bringing to you here today is actually pulled from our application guides in terms of that application of code. So I'm hoping you'll come check out our website at some point after today. But let's get started into this particular session about making the grade, just thinking about envelope. And first, I always do this. All of you who have seen all of my classes and trainings know I always like to start with, why are we here to begin with? An introduction into the energy code. So California has had a very aggressive past in terms of energy efficiency standards. Started with because of the oil embargo back in the 70s about increasing building efficiency being one of the most realized way of achieving reduction of energy use, and especially energy use of outside resources such as oil. And that has been the basis of the Energy Code, which started with the Warren-Alquist Act, about improving building efficiency. And building efficiency starts with the envelope, because that in part dictates our HVAC system loads and even our water heating loads, and also how we might use less lighting if we have more day lighting. We have some new goals associated with our standards now that we're moving through time. And that's all about reducing greenhouse gases. So we are still holding true to the primary goal of the Energy Code, which is building efficiency, and adding then to it that reduction of greenhouse gases and really increasing that portfolio and use of renewable energy. What I find a lot of people might not know is one of the founding principles behind the Warren-Alquist Act and how the Energy Code is developed is that every single code requirement, before it can be adopted, has to go through pretty stringent studies to show that it is cost effective, that the energy saved because of that code requirement will save enough energy to pay for itself over the lifetime of that particular building feature. And this is always so interesting when we go through this process. We're in the process of that, all of that studying, and what does the next code language look like for the next 2022 code cycle. And it's always fascinating for me to see the science that goes on behind the code. We also measure energy in a very unique fashion. This is very unique to California. We don't measure electricity. We don't measure therms. We don't even measure cost of energy like LEED does. We measure time-dependent value. What time of the day is energy being used? All of us are shifting to time of use rates here in California. It's depending upon where you are, happening sooner versus later. And that's all about where there is excess energy on the grid. Let's say earlier in the day when there's sunshine, but we don't have high cooling loads because air conditioners haven't kicked in yet, versus then when there's a lot of demand on the grid, which is going to be from about 4 in the afternoon till when the sun goes down, about 9 p.m. at night. So where our crunches are, that angst of how we're producing and realizing the energy use within buildings is changing in California as we have more and more renewables being brought onto the system, into our grid. It's also dependent upon where you are. Energy use here, I'm in the Bay Area up here in Northern California, looks and feels very different than if you're more inland, let's say in Sacramento or even Palm Desert or even up in the mountains. So we have 16 different climate zones in California, and all of that's taken into consideration of how we measure energy savings and efficiency. And then it's also dependent on the value of the energy being used. Is it electricity? Is it renewable energy? Is it natural gas energy? And one of the shifts that we're seeing in what we call our TDV multipliers is that that value associated with natural gas is shifting. And we're going to see that impact to our building compliance modeling in the next 2022 code cycle, as natural gas has more of a higher value in terms of where our TDV evaluations take us in terms of building design features. It's also very interesting. It's such an amazing time to be an energy consultant. So we do have our 16 climate zones that really look at the different humidity, elevation, temperatures, and weather patterns associated with that area to look at, is this a cooling climate zone, meaning I am using a lot of air conditioning to maintain a comfortable indoor environment, or am I using more heating energy because it's so cold outside and I'm using more heating energy to be comfortable? And then how many days throughout the year? We have certain climate zones, like climate zone 10 is very unique because it's equally hot and equally cold. So those building designs really have to think about how are they preventing thermal infiltration, but also how are they encouraging thermal energy on cold, sunny days. So you as architects get a lot, you have the hardest jobs, I think, because we can't build the same building everywhere and expect it to perform the same. We need architects to be aware of where is that building going to be located in terms of our extreme climate zones 14, 15, and 16. 14 and 15 are desert and they get awfully cold, and 16 is all about snow staying on the ground. So we have some extreme temperature changes going on in those areas versus it's just gosh dang hot out there, which is most of California. That's pretty much all of the central valley of California. Our mild climate zones, I always like to say, yeah, this explains why real estate is so expensive in climate zone 6 and 7, because honestly, you don't even need walls because it's just pretty moderate in those areas. And then our cooler climate zones where we're using more heating energy, but not to that extreme level like climate zone 16. And that's up in Northern California and Eureka area. Here in the Bay Area, climate zone 3, where we get a lot of fog in the summertime. That is our coldest time of the year, as a matter of fact. And climate zone 5, where it's still on that coastal area, it's not extreme, and it's getting pretty cold. These are all things that are taken into consideration with the code requirements regarding the U factor requirements that we're going to be going over today. Now, I shouldn't have to tell this audience this at all, but the envelope is so incredibly important, not because it's using energy all by itself. It isn't. It's using energy the minute we are maintaining an environment using mechanical heating and or cooling. So my heating loads are specifically, the majority of those loads are coming because of infiltration, all the nooks and crannies associated with my building. And the buildings, you'll see that more and more our U factors are getting lower and lower and lower. And how the only way we really can achieve these really low U factors is by embracing the building and all of its framing that interrupts and creates infiltration with a continuous layer of insulation. So the lower the U factor on our assemblies go, the more the energy code is going, hey, we really need to talk about infiltration. Conduction loss, especially conduction loss through metal. Metal is the best conductor for energy that there is. And when we're talking about metal framing, metal Z-clips, so many architects forget about those Z-clips in terms of how we are attaching our exterior surfaces, which might even be insulation, but the minute I use metal Z-clips, I might have done my building some harm in terms of energy performance. Walls, usually because I have so much of them, have a big impact on my energy compliance numbers and my usage of heating loads. Roofs, because it's all about heat rises. What can I do to keep that building within the conditioned environment? Floors, I kind of tell people, floors, you know, it's not a big deal. If I have raised concrete floors, it's more of a big deal in my cooler climate zones, climate zone 1, 3, and 5, and especially 16. But otherwise, I'm not getting a lot of load impact due to my floor. Cooling loads are all about those windows. What is the performance of that window to prevent solar gain when the sun is hitting those windows? It could be because of a particular window product, or it could be because of your design. This is where architects get to flourish. What are we doing to offset when the sun is actually hitting windows at the certain times of the day? And let's think about what time of the day that is. Those are those peak conditions from 4 in the afternoon till 9 at night, because that's the peak load conditions on our grid that the energy code is trying to help offset so that we have a more harmonized grid in terms of energy usage and production. There is a lot of load that can be associated with the roof. The sun is hitting that roof all day long, especially with our non-residential buildings. How are we offsetting that heating load, the cooling load, because we're introducing heat? Well, that could be very much just prevent it from coming in the first place. And this is why we have rated cool roof requirements for all our non-residential buildings. It's all about preventing that heat from getting in there to begin with. Okay, so that's that nice overview of why are we here today? Why does the energy code do the things it does? And why is the envelope so important? So now let's look at compliance methods. Now, in the energy consulting world, I live and breathe these words, and sometimes I have to back up a little bit and make sure everyone in the room understands when I talk about mandatory measures versus prescriptive measures and the ability to engage the performance approach, and how important it is for us to figure out how we're doing this early on in the project and really work as a team. It's only been, I feel, the last decade that I, as an energy consultant, have even been invited to be part of the design team before design documents. Typically, I would see drawings at the DD stage, and they'd be like, okay, Gina, we're going for permit in 2 weeks. How quickly can you get me the forms? Well, that might have worked in previous code cycles with how aggressive and how tight we're getting down into energy savings. We have to start way, way earlier. And I am blessed to have an amazing group of clientele who bring me on at schematic design. And that's when you have to think energy. That's when you have to think who in your design team is responsible for making sure the building is assuring the needs and desires of the building owner and the state in terms of the energy code requirements of the building code. And we feel at Energy Code ACE, the only way to realize that is with an integrated design approach. I was just saying in the lobby right before we went live that I got an email from a client right before now, them going, hey, we got a plan check comment. And the plan check comment was, where's the envelope Title 24 calculations? Whew, that is like the worst time to be figuring out how your design is meeting the energy code is with a plan check comment. Unfortunately, I've had that happen more than once, and it's the most expensive time to figure out how you're going to meet the energy code. The building block to the energy code are mandatory measures. Mandatory measures apply equally across the board to all climate zones. They were measures that were found to be cost effective everywhere all the time. Again, it all comes down to cost effectiveness. And typically, my mandatory measures look exactly the same, whether it's new construction. The most inexpensive time to integrate energy efficiency measures is while we're designing and building for the first time, versus alterations to an existing building. Now, cost effectiveness gets a little squishy because it's a lot more expensive to integrate some of these building features to an existing infrastructure than it is to do it for the first time. But mandatory looks the same for both alterations and new construction. Now I have two methods to show compliance. Mandatory measures are all, you're doing this. This is not about compliance. This is your bare minimum. And I find a lot of my projects, especially the walls, are not meeting the bare minimum mandatory measure. So we have to talk about the fact that your building can't even be built yet until we talk about these mandatory minimums. Then we talk about, now, how are we going to show compliance? We have our prescriptive measures, which are now dependent on climate zone, especially for the envelope. The requirements will differ based on climate zone. Is a heating, cooling zone, climate zone? Is it an extreme climate zone? Is it a more moderate climate zone? And I can show compliance with just the envelope. I am doing a look at, hey, what's just going on for my envelope? Mechanical, you go do your thing. Electrical, you go do your thing, and let's all go work in our separate buckets and never talk to each other. That has been a standard design practice for many, many years now. We can use, alternatively, the performance approach. The performance approach, we do an energy model of the building, of your design, and it's every minute of 365 days of the year. These models can sometimes take hours to run. I have one on my desk right now. It takes 9 hours to run it. Every time someone was like, Gina, let's see if we can do it with our 19 insulation on the walls instead of our 21. Okay, it's going to be 9 hours, and I can maybe tell you tomorrow. And this is where I'm looking at my TDV energy use of exactly your design, at exactly your azimuth, at exactly your climate zone, and what's going on in terms of energy usage. And I can just run the model, just the envelope. My heat gain versus my heat loss. Where am I in terms of my budgets just for envelope? But if we really want to open up looking at flexibility measures, is what us energy consultants like to call it, is when I start then also bringing in my mechanical equipment that is meeting those loads and my lighting systems that are adding to those loads. And when I look at that entire built environment, where is that overall energy use? And that's how I can engage the most flexibility. It is also the way that must be pursued. If I have any reach codes that require, let's say I have to be 10% better than minimum, the only way you can show an overall percentage better than minimum is doing envelope, mechanical, and lighting all together in one performance calculation. That takes coordination, and it takes coordination that has to happen early on in a project. At the end of the day, we're going to get those compliance documents that says building complies. It's so exciting when it says building complies. And that's integrated into our design set as this is the checklist of how the design documents are meeting the code. They're not to take the place of the design documents. They're to be that verification against the design documents. So the trickiest thing is to make sure that what we're promising is being done to meet the code is actually what's designed, what's shown in the design documents, so that it can enable the contractor to build it appropriately. So let's take a deeper dive and look at our prescriptive measures when it comes to the envelope. Now, again, I can always use the prescriptive approach to show compliance. It is incredibly difficult to get an envelope to show compliance to the prescriptive method. It is very restrictive because every single building feature has to show compliance on its own. The walls, against the floors, against the roof, against the windows, against the skylights, all of it has to show compliance on its own with no wiggle room. Gina, yeah, I know I have a lot of windows, but I have a great wall. Great. You can't use the prescriptive method if you can't meet all of the minimum criteria of the prescriptive requirements. We talk a lot about the prescriptive method, and you're going to see that I'm about to talk an awful lot about the prescriptive requirements of your certain climate zones and your building features, because I love using the performance approach. This is where I really get to see what's going on with the building. It's also how I'm going about producing load calculations. Across the board, at some point, someone's modeling this building. If at a minimum, it's the mechanical engineer that dictates then the mechanical equipment sizing associated with the building and your design as architects. Again, in that performance approach, I can just do envelope, and it's going to trade off the windows against the floors and the walls and all of those opaque surfaces. Or I can include other features, such as mechanical systems, such as lighting systems. Maybe I just want to do mechanical and envelope. That's a very popular package. And I'm going to go and do lighting prescriptively. But remember, if we have any reach codes or if it's a lead building, that overall model, including everything, is what they're going to be asking you to provide to show how you're meeting those goals. So grading things. As Bill introduced this particular topic, we're going to talk about you being able to grade your building and your details in each of your assemblies. When we use the performance approach, the standard design, what you're being compared to every time we hit the calculate button, is the perfect prescriptive design. So it takes your design and then tweaks it to then meet the prescriptive requirements of the code. And then it compares it against the overall TDV use of your design. And as long as your design is equal or less than the standard design based on prescriptive measures, you show compliance. So our mandatory measures, remember I said those were the basic minimums, that you can't even build it unless you have those. That represents a non-passing grade, because you might be able to go down to as bad as a mandatory minimum using the performance approach, but you are now below par. You have to offset that with enough energy savings on the other side so that I can get an average score at a minimum of C, and a grade of C represents the perfect prescriptive building. But many of our projects these days are in reach code cities or our lead projects. They have to be better than C. C is just passing. And they need to be something better than 0. I need 10% better. I need 20% better. So typically, when I have a project that goes for reach codes or lead, or I have that extra measures or incentive or utility rebate programs, 10% is usually where those start. So 10% better than minimum, prescriptive minimum, usually is a grade A. B is anywhere between 0 and 10. My grade of C, you just made the grade. You don't have to retake this class. Is just meeting those prescriptive baselines with a score of 0 in your performance calculation. anything below 0 is not a passing grade when it comes to the energy code. And that's whenever you're going below the prescriptive minimums and you're going as low as maybe the mandatory baseline, but then you have to make sure where you're offsetting it. So I want to, this is a standard energy report. And I want all of you to promise me after today, Gina, I promise after today, I will always look at this. And instead of just shoving these forms in my drawings and not looking at them, I'm going to at least look at this. Because when I look at this, it's giving me an overview of how your design is doing. It's saying for space heating, your perfect prescriptive design has a TDV energy use of 9.31. Your design is at 19.67. You're almost using double the amount of energy than the building you're being compared to when it comes to space heating. Space heating is going to be insulation. It's going to be how well you did with infiltration. It's going to be all about that U factor associated with your building features. Space cooling, well, here you're doing a little bit worse. You're doing pretty okay. You're using your prescriptive minimum is 103 and you're at 119. You're using a little bit more than what you're being compared to. But you'll notice these percentages for heating and cooling are about the same, those compliance margins. This tells me that this is a cooling climate zone. Look how much bigger this cooling number is than the heating number. That tells me you're using a lot more cooling energy because you're in a place where there's a lot of sun going on and it really doesn't get that cold. Great. So that tells me if I'm going to suggest anything to you to improve on your building, even though you're using double your allowance of heating energy, I'm going to talk to you about cooling energy improvements. That is your window solar heat gain coefficient numbers. That's going to be your cool roof numbers. That's going to be your air conditioning efficiency numbers, because that's going to have a much bigger impact into that overall energy budget of the building. Fan energy is all about how often does your air conditioning have to turn on? And this usually is all about windows. The more window I have, the more often your air conditioner has to turn on because it's getting hot as the sun is getting access into the room, and it's cycling those fans on and off, on and off, on and off. So usually when I look at my fan numbers, that's telling me how good your window design is, how much window you have, and how good is your solar heat gain coefficient. This is telling me you've got a pretty gosh darn good window design. And I'm pretty happy with this. It also tells me that you're using a zonal system and not a single zone constant volume fan system. Domestic hot water, hopefully that just makes sense. And in terms of my lighting energy, that's all about heating being introduced into the space that now that cooling energy has to work even harder at. And of course, will lights use energy? You can see here that the only way I'm getting this building to work is because of my great window design and because of my lighting. So there are some features here that I can improve with the architect, with the architectural design, because that the majority of my energy savings that's trading off my negative numbers is lighting. And lighting's not part of your design bucket. What else could we do to the envelope to see about what's going on? But it's also why we decide and we sit down as a group early on. What are our goals? What do we have to do? Does this have to be, is this a minimally compliant building? Or does this have to be a LEED building, or meet a REACH code, or meet some requirements that were put into the planning approval? Am I going to go all electric? Am I going to use natural gas? Can I even use natural gas depending upon my city? These are all decisions that have to be made so much early on. I also find that the roof has to be discussed now. I usually have my first meetings with everyone at the table. I'm like, okay, let's talk about the roof. I had one just go this way a few months before COVID shut us all down. We're all in person. And they're like, Gina, why do you want to talk about the roof so early on? We're at schematic design. I'm like, I got to tell you, I need part of that roof for your PV system or your solar thermal system or your solar ready areas? And they're like, yeah, it's just 15% of the roof. It's so easy to get 15% of the roof. I'm like, okay. So then the mechanical engineer went, okay, this is what we're going to do mechanical design. And like, whoa, that took a big chunk of the roof. And then the commissioning agent came online and said, oh, and we have to have this much green roof or open space to meet our open space requirements. Then the general contractor got online and went, well, you know, we have to be considering egress for window cleaning, for fire, whatever. So that's all these areas of the roof we need. The owner and the architect then sat there and went, we don't have 15% that Gina needed at the very beginning of this meeting. We have to redesign the roof. So there are lots of reasons why you need to think about this early. That particular project, we completely changed the mechanical system so that we didn't have as much mechanical outdoor units scattered all over the roof and became more of a centralized location, giving us the area we need. We also then worked with how much of that open space could potentially be covered with PV panels on a structure. But then we had to really bring in our structural engineer in terms of what that was going to do to the wind loads. And was that even going to be possible with the architect in terms of height restrictions of the building? And this is, we're just talking about the roof right now. Imagine, let's talk more about the rest of the building, why it's so important to get everyone early on talking about energy and how it might impact design decisions. Because if I'm going to change my mechanical design specs and where I'm going to put stuff, doing that before I fully have designed the mechanical system is going to be a heck of a lot easier than when I already have a fully designed system and then I'm making changes. So I have some questions for you guys, and I'm hoping that we guys can put it into the chat, your answers here. So this is a real simple retail TI building. It's just a shell building. In your opinion, do you think we're going to have any issues with this particular design meeting the energy code? What do you guys think? Do you think you're going to have some issues, or do you think this is going to be easy peasy? Anyone want to put something out there in the chat? Hillary, is there something I'm not seeing in terms of people being able to respond to these interactive sections of?
They're putting some comments in the chat.
There we go. I had the wrong thing open, which is why I wasn't seeing. Okay, so I love hearing that. Why the heck do we even have these things hanging on this building if they're not actually shading the windows? I kind of like question that myself. I've got other people asking, well, what's the climate zone? Excellent, because this might be an absolute amazing design for a cooler climate zone, but it might not be so great in a hotter climate zone. And I have other people saying, I really want to know the orientation. Now, I got to tell you, I don't feel this is a ton of glass. So I feel almost any orientation, well, then I just really have to think about what my window spec is going to be. So I'm having some of you going, hey, we might have some issues depending upon that window spec, but it shouldn't be that difficult. And does anyone feel like this is going to be something where we need to get that whole design team in there now? Let's start it at schematic design. Yeah, I always want schematic design from the very beginning. So Hafsa, thank you for saying yes. Okay, I have another project for you. How about this one? In your opinion, do you think this project will have any issues meeting the energy code? Do you feel a collaborative design approach is the best way to approach this building? Hamid, I'm hoping that you're just being facetious by saying no. And I'm hearing a lot of you saying yes, and that collaboration is just essential. And part of what I might be discussing with my team as an energy consultant is how much of this is vision glass and how much of this is spandrel? And can we really talk about what the framing is associated with this glass. And it could be, there might be another wall built entirely on the inside of this glass facade. That's where my heat transfer is really being looked at in terms of overall performance of the building. But I can definitely see that my mechanical system is going to make or break this project. And how are we going to be able to design a building and a structure and an envelope that has then a mechanical system that can actually achieve what we want to do in terms of comfort? And yes, the performance approach is definitely going to be needed on that one. How about this beautiful, this is my dream home, by the way. I do hope someday to be on the water, and I want to have a nice, amazing view of the water. And I want to be someplace where it's not foggy all the time. What do you guys think of this? Do you think this particular project will have any issues meeting the energy code? Do you think for this residential home, we should be thinking about an integrated design approach? Yeah, you know, it's amazing to me how often I'll get these designs right before they go into the building department. And then they're like, yeah, I'm like, how are you hoping to achieve this look here? Because did you even think about the budget that was going to be associated with this being a dual pane thermally broken window product? They're like, no, Gina, this is single. Ah. So there are things that if we are brought on earlier, the more we can maybe bring a sense of reality to the project, to the budget. And what then, because the window products available to do this and meet the energy code and the structural loads at the same time here in California, we've narrowed it down tremendously in terms of what that even is going to look like. I had someone say, is there a project where the integrated design approach just isn't needed? I find some simple TI work, some simple tenant shell buildings, as long as we're thinking to those prescriptive minimums. Yeah, we don't always need the integrated design approach. Some simple houses, even custom houses, depending upon comparing it to what you're achieving in terms of energy efficiency against the code. That's really, I just have to look at the elevations and I can tell you in 2 seconds how much you need me and how early. So let's talk about our opaque surfaces in terms of what the code is expecting you to understand and be aware of as you're designing your buildings. So first thing is U factor versus R value. I always get an architect who goes, Gina, can I please talk to you about how you're supposed to do the math for a U factor? The U factor is the inverse of the assembly's R value. I'm like, yeah, in your world, but in my world, I'm in the energy code. And in the energy code, we base our U factors on these joint appendices in which the Energy Commission said, here's a table, because that's the best way to design an assembly, by the way, is with a table. And this is going to help you understand how we think energy moves through these assembly types. And you're going to use the U factors in these tables. I don't care what math you've done on your side in terms of how you've achieved a U factor. And you have some flexibility with non-residential, high-rise residential hotel motel buildings in which we get to use more of a layering effect and not these tables. But we still have limitations in terms of what materials we're allowed to use. You might say, hey, Gina, we're using, it's going to be a rammed earth building. There is not earth as a material for me to use as an energy consultant, because earth differs so much in terms of what is the makeup of clay in that earth, how much moisture is in that earth. So we already have to go, okay, how am I going to show compliance in a way that represents your design, but in a way that is conservative and appropriate to how the energy code looks, how energy goes through this particular assembly. So understand that the more creative you get with your assemblies, another reason to bring an energy consultant on early, because they have to figure out the best way to show compliance to that assembly in terms of the U factor limitations of how the energy code allows us to assign U factors. Metal assemblies just across the board. Metal goes through, energy goes through metal. It's a conductor. So there's all these special calculations that look at how are we using metal in an assembly and how are we preventing that transfer of energy with a thermal barrier. So lots of things need to go into under the hood of determining all of your assemblies, especially if they're unique. Something, and when I say unique for residential, low-rise residential construction, I mean anything other than a 2x4 or 2x6 wall. Anything else is unique in the energy code. So we have these beautiful tables that are broken out by climate zone. Do you see how we have 16 numbers across the top? And you'll see that not all of the columns underneath that look exactly the same. We have requirements. This is the prescriptive baseline. I have my roof requirements that are broken out separately from my wall requirements. I'm not even going to talk about floor with you guys today. And here I have another table that's just for single family. So we also have to be making sure that we're looking at the table that applies to our occupancy. Is it a single family home? Is it a multi-family building? The requirements differ because of how we use those buildings differently. So let's dive in a little bit deeper. I always want to remind people about those mandatory baselines, the minimum. How low can you go? And you can never, ever go lower. I'm going to go back one. Nowhere on these tables do you see the mandatory minimums. These are your prescriptive minimums. If you're using the prescriptive approach, you will do this or better, or walk away and go start looking at the performance approach. Mandatory, now we do look at overall weighted U factor in our value. So that's really nice in terms of getting some flexibility, especially sometimes at the roof, especially if I'm using insulation that might be sloped, such as a flat roof sloped towards roof drains. I am looking at an overall weighted U factor. So I have a mandatory minimum R value of R22 for a wood framed roof and a metal framed roof, R21 plus R14 continuous insulation, not interrupted by framing at all. So anytime you see plus in any of my materials here, the after the plus represents insulation not interrupted by anything. It's continuous. And this includes Z-clips that are spaced 24 inches on center or less. Z-clips are considered framing interruption if they are 24 inches on center or less. I get to ignore them if those Z-clips are greater than 24 inches on center. And you'll see I have an overall U factor of 0.043. But when I layer on top of that the prescriptive minimums, well, Gita, there's no U factor there. Low-rise residential is very unique because it is assumed that most single-family homes and low-rise multifamily buildings have an attic, and that we put ductwork in our attic. And that attic gets really hot, just like an oven. And we want to make sure we're looking at that attic and considering it as an oven. And what can we do to reduce the temperature of that attic during the hot points of the day? So what the Energy Code has done is they said you're going to put insulation in two places. In our climate zones in which you're using air conditioning, that's climate zones 4 and 8 through 16, you're going to put insulation below the roof deck, and you're going to put insulation on the ceiling of your attic, there at that floor. You're going to have it in both places. And you're going to have a vented attic. This is not representing an unvented attic. It is representing a vented attic. It's also representing that you have your roofing product on an airspace separating it from the roof sheathing. And if you do not have this very specific roof assembly, you have to use the performance approach. You have rafter roof, go use the performance approach. You're doing an unvented attic, go use the performance approach. You do not have an airspace below your roofing, you're using comp shingle, go use the performance approach. So this is a very specific assembly that sets the baseline for compliance in my hotter climate zones. Wall assembly. I have a U factor of 0.102, which represents R13 in a wood framed assembly. 0.071 for a 2x6 wall, which represents R20 blown in insulation in a wood framed assembly. If you're going to go metal framed, you have to meet these U factors, which is very difficult to do unless you have continuous insulation, not interrupted by framing, associated with your metal project. With all the rebuild efforts that are happening in California, metal is being brought to the table more and more often because it's more resilient. But we have to think about what happens to energy when we use more metal and how we have to think about encapsulating that metal framing with some sort of product that has a rated R value to achieve these very low U factors. These U factors, here we have now our prescriptive U factor requirements associated with most of our climate zones, a 0.048. That's a lot lower than 0.102, isn't it? So if you were using a performance approach and you were saying, hey, I'm going to do 2x4s with R13 because Gina said I only had it to meet the 0.102. How big of a penalty do you think you're going to get in your performance calculation when you're being compared to a 0.048? That is a huge penalty because remember, what do we have a lot of in our projects? We have a lot of walls. I can get this U factor in many different ways. I could do a 2x6 wood framed wall with R21 condensed bat between the framing plus R5 continuous insulation. This is going to be like a polystyrene product, a closed cell polystyrene. I really want R19, Gina. I don't like that R21 stuff. And maybe you're using mineral wool, which you can't get the R21 with mineral. Well, some you can get R23. I take that back. So a lot of this is what's the product that you're using. Let's see what the R values are associated with the product to then see what else we need to still do. I still have clients who are saying, I want the 2x4 wall, Gina. And this is usually associated with ADUs. They have a small footprint. They're close to the property lines. They don't have much wall depth allowed for them because of just where the building is and the type of building it is. I'm going to do 2x4 framing. Well, now I want 2 inches of rigid to be able to achieve this 0.048, which is going to be very difficult. How to read your performance calculations. So there's always this table in a performance calculation where it tells you about your opaque surface construction. It's telling you about your framing type. If you see wood here, but you know you have metal walls, you need to go back to whoever did your calcs and go explain this to me. Now, sometimes we have to do that because we're trying to show an equivalency to what your unique assembly is, but please always, always, always question it if it doesn't match your details. Here's the cavity R value. So here we have this garage wall that has no insulation in it at all. And I'm like, what? No insulation? Oh, it's a wall associated with unconditioned space, the garage, and the energy code does not have any insulation requirements for walls that are not enclosing conditioned space, such as my garage. My exterior walls to my conditioned space are R21 in a 2x6 framing member, 16 inches on center, with an additional R2 continuous insulation on the exterior of the wall. Hoping all of you are seeing where I'm seeing it says exterior is where that R2 is, that there's none on the interior face. I do have a question asking, where should the water barrier be on the outside with proposed 2x6 framing? Where should the moisture barrier be on the inside? I would, it depends. The moisture barrier most times is on the outside. That's why you'll see that good building science dictates that our insulation should be on the outside of our assembly, and that we have the ability to use that heated environment to help dry out the assembly. So put that water barrier on the outside so that you're preventing moisture from getting into your assembly in the first place. Now, there's so many different ways of doing it. That's another reason why I love using mineral wool as my rigid insulation on the exterior of the wall, because it could potentially be part of my rain barrier and water barrier assembly. Straw bale construction is becoming mainstream again. I know we've done, I think, 4 straw bale homes in the last 2 months, and it is a great, resilient product. So yeah, we're definitely seeing, I'm seeing SIPs all over again. That's a blast from the past also. So do look at your reports, make sure your details are aligning with what you thought you were designing. Things do look different for our non-residential buildings, high-rise residential buildings, that's 4 habitable stories or greater, and our hotel motel buildings. Again, we have a different table for our different occupancies. So we always want to be making sure we look at the right occupancies. And you'll see these 16 climate zones again, and our different building opaque features, our roofs, from our walls, from our floors. And you're going to see a lot more information about roofing products for our non-residential buildings because of the fact that these are buildings that are being occupied during the day as the sun is hitting that roof and bringing heat into the building. How are we making sure it's not then going to use air conditioning at the worst time of the day when we consider our TDB energy use? What is our mandatory minimum or maximum U factor that we're talking about? Now, it does depend upon your different assembly types. I decided to just concentrate on wood framed or other, which does incorporate metal framing. It's a 0.043. That's pretty similar to what we saw with residential. And then prescriptively, it's 0.034. I have not had an issue with most of the roofs I see in meeting this U factor, though I'll have some architects that are like, Gina, I gave you 5 inches of open cell polystyrene and I'm sloping it towards the roof drains. You should be happy. And I'm like, well, that's an overall weighted average of about R22, and you're being compared to R25. So whereas, yes, you did give me 5 inches of something, but you're sloping them, so my overall weighted U factor is getting higher. And the fact that you're being compared to an R25 roof, I'm not even getting a C, I'm still getting a D with your assembly because I'm not meeting that prescriptive U factor. Walls, metal walls versus wood walls are important to understand. I like to concentrate on metal walls because that's what I see more often in my non-residential high-rise residential construction due to fire rating assemblies. Metal framed mandatory U factor 0.151. This was something we saw new in the last code cycle that I'm not even sure a lot of people have absorbed. This is where we find the biggest issue with our clients. They are not meeting this mandatory maximum overall weighted U factor. And a 0.151 represents about a 6-inch metal wall with R2 continuous insulation. Or it could be a 6-inch wall with, it's a 1-hour rated wall with 2 layers of 5/8 gyp on both sides, would be another way that I can get this 0.151. So some of the biggest issues we have is the walls we're seeing, the exterior walls and the demising walls. Demising walls are walls that separate conditioned space from enclosed unconditioned space like that parking garage. These are the walls I'm looking at to see how you're achieving compliance. What you're being compared to in the performance calculation and what you have to meet as a prescriptive minimum for your exterior walls in most climate zones is a 0.062. 0.062 is a heck of a lot different than 0.151. A 0.151 can always be used for my demising walls, those walls in the garage between my conditioned and unconditioned spaces. But look at this. I mean, these numbers have not changed for a long time in the code. This represents, let's say most of my clients do 6-inch metal wall. That's 2 inches of polyisocyanurate on the exterior of the wall, equivalent of R11, for me to achieve the prescriptive minimum. Now, more and more of my clients are just going, yeah, we got it. We're doing the continuous insulation. Where I find the issue is when it comes to the Z-clips. Remember, Z-clips, 24 inches, if they're metal Z-clips, and I don't find isolated Z-clips or fiberglass Z-clips being used as often as metal Z-clips. If they're 24 inches on center or less, they are considered metal framing, and you no longer have continuous insulation associated with your assembly. So we have to be thinking about how we are attaching everything and its effect on the overall energy performance of the building. Mass walls, we look at a little bit differently. Mass moves through that, energy moves through mass differently. And it's usually about what are we doing for an additional framed wall or just adding insulation. Sometimes I see people just glue insulation, rigid insulation onto that mass wall in terms of where my insulated product is. Now, as a mandatory requirement, we don't have really any insulation requirements depending upon how thick the insulation is, the concrete is. But there's no way to achieve this 0.17 that represents most of my climate zones without some sort of insulation, whether that's insulation interrupted by metal framing. Here, I can do a 6-inch metal wall that interrupts R19 bad insulation. That works. Or I can use a combination of maybe 3-inch plus some continuous insulation. So there's things we really have to be thinking about in terms of how we deal with our mass walls. Again, this table looks very familiar. It's very similar to what we saw for single family and low-rise multifamily buildings. We have our framing type. Please make sure that that is equal or represents well your assembly. The cavity insulation, so this is any insulation that's interrupted by framing. So if you're using Z-clips, 18 inches on center, then all of a sudden that insulation will be considered cavity insulation versus the continuous insulation. Now you'll see it doesn't matter whether it's on the inside or the outside. When it comes to our non-residential high-rise res, hotel, motel calculations, there's some slight difference in terms of that overall U factor, but it's really not that big of a deal in terms of where is the continuous insulation. I love having the continuous insulation in the middle of the wall. How about a staggered stud wall? How about I have a framed wall on the exterior that has all of my surface treatments, my water barrier, et cetera, and so forth. I have an air gap. And then I have some continuous insulation, maybe rigid, that is associated with the interior wall. So now I almost have 3 walls in one in terms of how I'm showing compliance and where I am figuring out my continuous insulation. So I want you guys to grade this assembly in the chat. Give me, does it get an A, B? Does it get a C, a barely passing grade, or is it not meeting prescriptive at all? What do you guys think about this particular wall? Henry's saying A, B. Anyone want to agree? Okay, so it's excellent. So this is a staggered stud wall. And I find it's not so expensive to build, but it's expensive to insulate. Insulating that properly, where we're not just weaving bad insulation in there and just why even do what we did, because I didn't do anything. And making sure our insulation is meeting all 6 sides of all air barriers, left, right, front, back, top, bottom, is really important to get that R value of the overall U factor that we're trying to achieve. I am finding more and more often staggered stud is starting to happen in my high-rise buildings, usually in those demising walls, because also they might be plumbing walls and other reasons why we want to have that cavity. Well, then I get to take advantage of it as long as we're insulating it well. And does this type of wall have a shear value? I've definitely seen it in terms of shear value if I have, depending upon the product I'm putting on either side of it, either whether I'm using 5/8 plywood or even maybe it's a fire rated wall and I have 2 layers of 5/8 gyp. So there could be shear associated with this wall, but it's going to be more about the exterior surfaces, not the framing. What do you guys think of this one? A, B, C, D, F. I got someone saying, yeah, F, 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 D, F. Where's the insulation even gonna go? And whenever any insulation I have in there, yeah, wood does have some insulating value to it, but it's not giving me the bang for the buck. And I really have to think hard about my framing details and how am I achieving my structural load and doing it right. How about this one? Here I've got a high-rise multifamily building. How would you guys grade this assembly? I got F's and C's. I am more on the side of F's, I got to tell you guys. Does anyone want to say, okay, excellent, Bronwyn saying it depends on the Z-girts. I hope all of us can agree that those Z-girts are definitely closer than 24 inches on center. There is definitely some thermal bridging going on here. So we put all of this expense into this closed cell insulation, but then interrupted it horribly with all of this metal Z-girt. Ah, so sad, so sad. What do you guys think about this roof assembly? This is a TI shell building. I've got some, let's say we've got, this is R19 bad insulation on the underside of the roof here for my commercial TI shell building. What do you think? Hamid is the only one here that's got this one right. If anyone remembers, you need an equivalency of R30, and I only have R19 here. So this isn't cutting it. Now, I might additionally have some rigid insulation on top of this roof that I'm also using to slope towards the roof drains. And I can always combine layers of insulation. That is perfectly fine. I, as your energy consultant, am going to go, ooh, I've got interruption of your metal I-beams here, and I'm taking a hit for that. I might want to talk to you about doing a layer of spray insulation on there to totally break that thermal bridging. But I'd really want to talk to you about putting some insulation above the roof and having that insulation on the outside of my assembly so that I can achieve the best energy performance possible. Now, I know this is a bit blurry. What do you guys think about this roof? Mary, you're right. Rigid could bring that to a C. Yeah, excellent. This is where I have, it's actually SIPs being used above the roof, and then the roofing will go on top of this. This is the place we want to put our insulation, on the outside of all of our assemblies. We want to have it on that cold side so our warm side can be drying out the assembly. This is fantastic. Bronwyn, I know you're saying about air infiltration. This is, you really can't tell, it will be one continuous layer of the SIPs up there, so there is no infiltration. And that's the other thing that's absolutely gorgeously beautiful about this particular assembly. Taped at the seams 100%. Otherwise, I would fire them, because honestly, roofers who wouldn't tape that really should never, ever be hired again. What resources do I have in Energy Code ACE that just talk about the envelope? We have a fact sheet just on opaque envelope. A lot of what we talked about, we have one for residential and we have one for non-residential. We also have our application guides where some of this imagery came from, and which we have one for non-residential envelope and we have one for residential envelope. Let's now talk about fenestration. Yay! So fenestration is really honestly that one thing on the envelope that a lot of energy can be lost. I find it all comes down to the window design. Now, the first thing and the hardest conversation I have with all of my clients, and it's usually the contractors, I don't know if I have any contractors in the room today, the hardest conversation is the value of your product. Are we using a default value, which represents any window known to mankind, and you don't have to work hard at that number at all? Default values can only be used in the performance approach and always will be at a penalty. So there are no default values that will meet the prescriptive requirements of the code. So it is automatically always a D or an F. Now, it might be an amazing window from Italy, but if it is not NFRC certified or rated, it gets the grade of a D or an F. Even though you think it might perform well, the state of California wants it tested. How is it performing in terms of testing values through the National Fenestration Rating Council, a lab that has been certified and approved by them to do this testing? Now, we do have the ability to use an NA6 formula, but it's limited to 200 square feet or less of site-built glass, and it's going away in the next code cycle, so don't even pretend I didn't even say anything about that method. It's between NFRC products or defaults. And time and time and time again, I find you might put a lot of work into speccing a product that is to be NFRC certified, but the contractor who is responsible for getting that certificate never, ever does it. I then have to go back and rerun it as default values, and it's not passing anymore. I have a project on my plate right now that they're losing hundreds of thousands of incentive money because the contractor did not get the NFRC certificates as was required by the specifications put in play by the architect in the design drawings. It's really sad. This is what an NFRC certificate looks like. This is such a unique beast out there. This is what the unicorn looks like in the wild. It's a virtual simulation for our non-residential buildings. For our residential buildings, it is, all of us have seen the labels. I decided not to show you NFRC labels because we all know what those look like. I want to talk about certificates that are associated with our site-built glass for non-residential, high-rise res, and hotel motel buildings, in which they'll do a virtual simulation of the glass type. Great, you're going to spec SolarBand 70 XL Clear. Yes, I love it. You're going to spec that it's dual pane. Yay, I love it. And then you're going to put together a very special framing feature because you want a certain look. Oh, because now I might have to get that framing tested so that I can get the overall certified U-Factor, SHGC, and VT that is used in the performance calculations as supporting how your building is performing. So take a look at this lovely project. Which fenestration product do you think is going to work for this building? Will they have to use an NFRC labeled product that we use for residential homes? Will they use an NFRC certified product that does the virtual simulation through an NFRC lab? Can we use the NA6 center glass formula that's limited to 200 square feet of site-built glass? Or can we use default on this project? I've got one. Yay, you guys are getting it. It's definitely the only way this building is going to work. This is a lot of site-built glass. It's way over 200, is by doing an NFRC certified product. And Bronwyn, I am not going to argue with you whether this is a racket or not. I've seen a lot of products out there that are crap, and they do not follow up when they are actually finally tested as what that company promised. So where are we going for our values? So when we talk about fenestration, we also have a U-Factor. So this is all about the frame type and whether it's single pane, dual pane, or even potentially triple paned. We have a maximum U-Factor of 0.58, and it is an overall weighted U-Factor, just like we saw for our opaque assemblies. With some exceptions, this is usually taking into play that sometimes if we have fire-rated windows, we need some leniency on whether they're thermally broken or not. Prescriptively, that U-Factor is now 0.30. There's a big difference between 0.30 and 0.58. We also have a prescriptive solar heat gain coefficient of 0.23 in most climate zones. There are no solar heat gain coefficient requirements for climate zones 1, 3, 5, and 16. These are climate zones in which getting solar gained through the windows at the right place in terms of your design actually bring in free heat on a sunny, cold winter day. And we want to take advantage of that in terms of energy savings, in terms of space heating energy. How much window can I have? So for residential, that's single family or low-rise multifamily, you get 20% of your conditioned floor area. It's not much. Now this home you're seeing here, this meets these requirements just fine. It meets the 5% west facing restriction, in terms of climate zones 1, 3, 5, and 16, those heating climate zones. So really thinking about it, remember we looked at Gina's dream home that was looking out over the sunset? It was an awful lot of glass, probably might be over my 20%, and I definitely am over my 5% west facing. If I am not in climate zone 3, all these other climate zones don't have coastal areas. Now things look a little bit differently for our non-residential, high-rise res, and hotel motel buildings. Now it's not based on climate zone. It's based on window type. Is it a fixed window, like a punched window? Is it an operable window? Is it a curtain wall or storefront window, which is typically site built? Or is it a glass door? A glass door is defined as any door that has more than 25% of its surface area is glass versus opaque. We have no mandatory maximum U factor for these building types. We do for single family, low-rise multifamily, but not here. So that gives us a little bit more flexibility, especially when we have fire-rated assemblies in terms of what we have to do in terms of our window product. But this U factor, these U factors are pretty gosh darn aggressive. In fact, what do they typically represent? They typically represent a thermally broken, dual paned product. The solar heat gain coefficient here typically represents a low E triple or a dark tint, which is going to screw you up when we start talking about visible transmittance. These numbers represent a clear product, so that low E triple, and would not represent at all a darkly tinted number, because the higher the visible transmittance, the more we're bringing in natural light and the less we're using electric lights. So that visible transmittance is all about how can we save lighting energy, which is why we don't have visible transmittant requirements for single family, because of the fact that that's not a really big part of the load in terms of energy savings. So that solar heat gain coefficient for non-residential, high-rise res, hotel, motel, we get to take into consideration in terms of how that window is performing based on your design. This could be, in this particular scenario, they designed these shading devices at just the right place, at just the right depth, so that during the peak use conditions of the building, between that 4 and 9 p.m., majority of the window opening is shaded. This is pretty beautiful and allows us to potentially have a less expensive glass product that's clear, that might be more of the look and feel that we want for the building. Again, visible transmittance is about how much sunlight is getting into the space, but we also want that window product to reject the heat gain. So it's a very careful balance. Chris is asking, is this U value applied to all directional envelope walls? Yes, it is. You'll see that for storefront and curtain wall, it was a 0.41 U factor, even whether it's on the west or not. That U factor is across the board, all azimuths or elevations. The SHGC is also the same on all azimuths, but when we do the performance approach, we see that there's more give and take when we do that model regarding solar heat gain coefficient. VT across the board also. You will see fenestration amount does depend on orientation or azimuth. So for these building types, we get 40% of our window to wall ratio. It's nothing to do with conditioned floor area now. It's about how much exterior wall do you have and how much of that is window. And it's vision glass, not spandrel, by the way. Spandrel is considered an opaque surface. You get 40% of that entire window area, all 4 orientations combined. You have to not exceed 40% on just your west elevation, and you cannot exceed 5% of skylight to roof ratio. So tell me what you think. Grade this puppy. What do you think about this window to wall ratio for this commercial building? No one has opinions here? Bronwyn's giving me an F. I got one C. I almost want to ask you, Leon, why are you giving this? Nathaniel and Ellen is giving me a C. I'm kind of wondering why. I can see that I have a little bit of spandrel at the top, but that the majority of this facade is vision glass. This is over 40% window to wall ratio. Now, what I have to ask is this what they did to all orientations or just this one? Because remember, we get the 40% for all the walls combined. And then I have to ask, is this west facing? Because this is west facing, this is an issue. If this is south facing and all of my walls combined don't exceed the 40%, then I'm okay. And Karen's saying, well, what if it's dynamic glazing? Well, Karen, if it's dynamic glazing, and dynamic glazing, I get to take the value of the lowest solar heat gain coefficient in my calculations, but only if it's a automatic dynamic glazing, meaning there is a control that when the sun is hitting this facade, it darkens the glass. So that usually there's an electric current that goes into the gas that's between the two pieces of glass that then darkens it. And I get to use that lower solar heat gain coefficient when I have dynamic glazing, which is going to be great. What do you bet I'm only just meeting the prescriptive requirements, though? It's kind of hard to do better than that. And I have an awful lot of glass. I do get to use the visible transmittance of it being in clear, though. So dynamic glazing gives me the best of both worlds, a low solar heat gain coefficient and a high visible transmittance number. And so excellent. You guys did fantastic here. How are you going to grade the product type? This is a single pane, metal framed, clear storefront. How are they doing? This is my #1 product asked of all the buildings I do in San Francisco. #1, every single time. And all of you are getting it. That is an F. There's an awful lot that has to be done for me to get out of this hole. I can do it because I don't have any maximum U factor requirements for this building type. It's going to be extremely difficult. We have some great resources associated with fenestration. We have a fenestration fact sheet for both non-residential and, yes, you've guessed it, residential. We also have some great trigger sheets. These are for alteration projects, which are happening a lot, especially with some of the new earthquake structural requirements that were due 2 years ago. And now only some people are going, oh, you really meant it? You're going to find me every day. I haven't done it. It's amazing how many projects are happening that way. These trigger sheets help with how does the code apply in an alteration. We have one for non-residential and we have one for residential. Now we want to get an A, right? Does anyone here want to get an F? Or do you want all your buildings to get an A? We're all overachievers here, right? So I'm hoping this overall messaging behind start early. Start early, put the majority of the efforts into how you're going to achieve your goals, and especially getting anything better than just a minimum passing grade. Yeah, Judith, I want like quadruple A. Hi, Judith, it's been so long. And schematic design is the place that needs to be. You get a little bit of wiggle room at design development, but if you got caught not doing your energy calcs for the envelope during construction documents when you went for permit, oh my God, that's like quadruple minus F. That is the most expensive time to be considering that. Cost went up tremendously and the effort went up tremendously. All of us design professionals, we don't come cheap. This project's going to be LEED, and I want you to think about energy only. What envelope features concern you the most for this single family home? How are you going to achieve your LEED Platinum status? How are you going to mitigate those concerns that you have? What concerns you guys the most here? I know there's a couple that just jump out at me. I'd want to know about orientation, Leon. That's an excellent question I'd want to be asking. And let's say this is facing east. Judith, the glass, the amount of glass really has me concerned. And when we have, look at downstairs, there is no framing there. No framing at all down there. What type of glass is that? That tells me it's single. Look at in the right-hand corner, we have that invisible corner. You can't do that with dual pane. That's single pane. Look how much concrete we have. Yes, Wesley, the thin roof structure. Nano wall might be an excellent way to mitigate this. Really be thinking about your window products. Excellent. How else might you guys mitigate? Give the homeowner what they want, but still be able to meet the energy code and not have them sell their children to pay their utility bill each month. Heather's like, hey, just don't even give the building owner this as an option. Say, hey, let's look at something else. Oh, it's not a heated or cooled building. That means it can't be an occupied building either, because the residential code requires that all residential occupied spaces must meet a minimum 68 degrees Fahrenheit, 3 feet above the floor and 3 feet in from all exterior surfaces. So Brian, that's not an option. Let me tell you, I've had architects say, well, what if we just have this pool building not be a heated building? Okay, then it's not a habitable space. Have an acre of PV, really think about your renewables. Understanding some different, are there tools to help with understanding carbon and the materials? I could swear there is a class that's coming up very soon about that. And yes, I do know there is some great stuff out there. Jacqueline's saying, hey, SIPs, yeah, hey, maybe we give the look of this concrete wall, but we do it with our finish and we use SIPs. I love that idea. Excellent. How about this one, guys? So this is going to be an office building. It's going to be LEED Platinum. What envelope features concern you the most? And how would you mitigate those concerns? First of all, I mean, just looking at the design, do you guys think there are any issues? Yeah, there is an awful lot of glass. Leon, that's excellent. I feel that potentially they might be over their 40% window to wall ratio. And I'd really want to be looking at what is that window product, but it has some good shading. So I really do love that they're utilizing features of the building and doing some interesting things to incorporate shading and also reducing that glare, which makes me pretty excited. So I honestly have to say the biggest thing that concerns me with this building might be the assemblies in terms of infiltration and continuous. I just feel there could be a lot of nooks and crannies associated with this building and the window product. Winter sun angle, yeah, is it too dark? Do we have all of these light louvers at the right angles so that we are achieving what we want to achieve? Yeah, these are all excellent things. I want to tell you about this. These are all little teasers from our full day classes that we have. We have one for non-residential buildings and we have one for residential buildings. They are 2-day classes. Some of them are 3. This is not a 3-day class. It's a 2-day class where it's 3.5 hours each day. We have one coming up in just a couple of weeks, June 7th and 8th. Come and join me if you want to come and talk about non-residential buildings more in depth, and we'll really go into detail on some of the stuff, plus other things like commissioning, other things like daylighting. That's so important to our non-residential buildings. And we'll talk more about reach codes and electrification in that class also. Residential, really do talk about these U factors are really, really low. And what are we looking at? And what are our different mechanical system choices that can help give us the residential building we want? And there's a lot of discussion on what represents an all-electric residential building versus a mixed fuel. You are going to get a copy of these slides. So all of this is integrated into that slide deck. There are some other videos, as we talked about earlier, that we did that are recorded through AIA California that we did last year about what's new for this particular code cycle. And we did one just looking at ADUs. Remember, we talked about how those walls are really a concern when we look at our small ADU footprints. And those are available as recordings through your AIA California membership. You can reach me anytime at this particular email address. I wouldn't suggest calling me because of the fact that I am usually teaching all the time, but I do answer email. Jill Marver is the manager of our program at Energy Code ACE, and this is our contact information. And you can always go to our website, and this particular link will give you direct access to all sorts of different areas of getting straight to who you want. And the info on ADUs, that recording, again, I would make sure you get this handout, but that particular recording is on the AIA California site. And I bet Hillary can tell you more about that. Hillary?
Hi, everyone. Yes, I will share a link to where you guys can find all of these recordings and additional information and resources that Gina has put together for us.
All right, well, thank you, Gina. We were hoping to get a few questions in. I'm afraid we've run out of time, but I wouldn't have missed a minute of your presentation, so good job. What would you be willing to answer some of the, we've got 10 questions in the chat,
Yes.
and the question thing, if you could answer those online, we can make sure those get emailed out to all the participants, and we'd really appreciate it if you could do that. I'm
going to copy those, so I've got them once we get out of here, and email those to you.
Fantastic. Well, I want to give you a big thank you. This has been really impressive and an excellent presentation. I would ask you to pass our thanks on to Energy Code ACE as well for their help in this presentation. So some housekeeping for all of you who are attending. If you made it this far, California AIA staff will submit your AIA CE credits. They should appear on your transcript in a few weeks. As always, more resources and tools can be found on AIA California's website, and that's at www.aiacalifornia.org/climate-action/. And more details on other 2021 Climate Action Series webinars will be shared with you on email. So thanks for all of you for joining us, and we hope to see you on the next webinar. And thanks again to Gina.
Thank you, everyone.